To determine whether ordered pairs are a solution, we're going to treat them by putting this pair into each equation and see if it gets the same number. So if we put 4 in for x and -1 in for y, and then put 4 in for x, and -1 in for y, we see if they get the right answer. So we have 4 minus 2 equals 2, which is true. And then we have 4 plus 2 equals 6, which is also true. So 4, -1 is a solution. A solution has to meet both equations, so I'm going to do the next one. So I'm going to put a -4 in for x plus 2, and I'm going to put a 3 in for y equals 2. And then I'm going to do the other equation, -4 minus 2 with 3 equals 6. And let's go through and solve this. As a -4 plus 6 equals 2, that's true. And if I go a -4 minus 6 equals 6, I get a -10. This one's not true. And since this one is not true, this is not a solution. So it must meet both equations, not just one of them, to be a solution. And in this case, the second one is not. The first one is, yes, it is a solution. Way of solving systems of equations, that means when you have two equations, is by graphing. And where the graphs cross is a solution. So if I graph this first one in red, and we go back to our slope-intercept form, I would go to a +2, put a dot, and I would go down 3 and to the right 1, and I do my line. Then I graph the other equation. I go down to 6, 1, 2, 3, 4, 5, 6. -6, I mean, and go up 5, 1, 2, 3, 4, 5, and over 1. And draw that, which might be pretty obvious, that it crosses right here at that point. That is the solution to the system. So in this case, 1 looks like 1, -1, -1 would work. So if we were to use the last method and substitute this into both those, it would work for both of them. But graphing makes it a little easier. So we're going to graph these, and sometimes they don't have a solution. So let's graph and see what that means. So if I go to -1, I'm doing this one in red, and I go up 2 to the right 1, and I draw my line, and then I do the other one in blue. I go to 3, 1, 2, 3. I go up 2 over 1, and I draw this line. We have what's called parallel lines because they have the same slope, and if you recognize they have the same slope, you have no solutions. And the reason why you have no solutions is because the lines never cross. They are parallel lines. So the answer can be shown in a graph by showing parallel lines, or you can look right at the beginning and see that the slopes are the same, and then you would give your answer of no solution. Next and third final type is, let's graph this one, and I'm going to put the red one in slope-intercept form, so it'll be y equals a -2x plus 3. And so I can go to the 3, go down 2 into the right 1, and create my line. Then I go to my blue one, which once again, it also has to be put in slope-intercept form. So I have to subtract the 4x, and then divide everything by 2, which puts it as a -2x plus 3. So now I go to the 3, and I go down 2 into the right 1, I end up on the same line. If you look closely at the equations I've created, they're exact same equations. So if we get the exact same equations, we have what's called infinite solutions, which basically means they're the same line. Same line, which the graph shows that as well.